Hello everyone, welcome to SquareRoot Central. In this video, we will be looking at Theorem 3 of 7 pertaining to real numbers. Now as you can see on the screen, the Theorem 3 states that let P be any prime number if it is the case, and if P divides A square, then P divides A, where A is any positive integer. So let us begin with the first 4 prime numbers. We will be using a small number right now, at least for example sake we will be using a small number. That doesn't mean that this only works with these prime numbers, it works for any prime number. The theorem is applicable for any prime number. Let's take an example. Let us consider P to be a prime number as 3, and let's consider A square to be 144. Now finding out squares and square roots of numbers, we have a video on the channel. There is an easy way. You can find the link in the description below. Go through the same if you want to. So if we say A square is 144, we would have A as 12. Now let us do one thing. Let us use 144 and let's factorize 144 based on the prime numbers that we have, and let's see what do we get. What is the unique factors? What are the unique factors that we get for the number 144? So beginning with our prime number 2, if we divide 144 by the number 2, we would be getting 72. Once again, let's see if 72 is divided by 2. So it is. If we divide 72 by the number 2, we would be getting 36. 36, once again, if we divide by the number 2, we would be getting the number 18. 18 again will be divided by 2, or we can divide 18 by the number 2 or by the prime factor 2. 18 divided by 2, we get the number 9. 9, when we divide it by 2, it doesn't go, we will be having a remainder 1, so we'll be dividing 9 by the number 3. Once we divide 9 by 3, we get the number 3. 3 is a prime number, so it will either be divided by 1 or itself, so we divide 3 by the number 3 to get the number 1. So this here is something we did with the help of our previous theorem. The description, the link to that video is in the description below. You can go through the same. So 144, we factorize 144, we have 2 4 times and 2 times 3. So we can write 144 as 2 to the power 4 multiplied by 3 to the power 2, or 3 square. Now if we divide 144 by P, that is P is 3 here. So if we divide 144 by 3, we get 2 4 times and 3 ones. So 144 divided by P can be written as 2 to the power 4 multiplied by 3 to the power 1. That is, 144 is completely divisible by P. Now let us see what happens with when we find out the square root of 144, because 144 is A. If we find out the square root of A square, we'll get A. So when we do a square root of 144, we would be reducing two common factors to 1. So we will be having square root of 144 as 2 multiplied by 2 multiplied by 3. This can be written as 2 to the power 2 multiplied by 3. Now let us try and divide divide the square root of 144 by P. P, as you can see, is the number 3. So if we divide the square root of 144 by 3, what do we get? We have 2 multiplied by 2 remaining, or 2 factors of 2 remaining. Now 144, square root of 144 can also be written as 12, as you can see on the screen. Root 144 changed to the number 12. So 12 divided by P is 2 and 2. We have 2 common 2's there. That can be written as 2 to the power 2. So square root of 144 or 12 is also completely divisible by the number 3. This goes on to prove that for every prime number, if P divides A square, then P also divides A. So that's it for this video, guys. If you have any questions, please mention them in the comments below. Do check out our other videos to understand what real numbers are and understand the last two theorems pertaining to the same. Also, for any inquiries or queries or questions, write to us, follow us on social media. This is SquareRoot Central signing out.